Hello, my lovely students. How are you doing today? Hope doing well. Welcome once again to Dr. Soros's classes. We are back again with another video on group theory. This time it's Euler's phi function. Very important topic, students. Let's mark that. Let's mark that with a thick red color. Stars means what? Very important topic to consider. What is that? It's Euler's phi equation function, phi function. With the help of this, we will be able to find the number of what is that called? Cyclic subgroups. We will be able to find by the number of cyclic subgroups. This is actually a function telling you. This is a talking about the function. We will be finding the number of cyclic subgroups using this formula. Okay. Let's just highlight this part for you using this one. Oh God. Actually mixing color with color. Okay, just remove that part for you and highlight it with yellow. We'll be using this formula. Okay, but for that you must know Euler's function. All right, so let us continue with Euler's function. What does it say, students? It says, for understand when I'm reading, okay, for any positive integer n. So n is a positive integer. Let's write n is greater than equal to 0. Okay, positive integer greater than equal to 0. Then phi n denotes the number of those positive integers. Phi n denotes what? It denotes the number of those positive integers which are less than n and are relatively prime to n. They are less than n. Okay, phi n denotes the number of those positive integers which are less than n and are relatively prime to n is called Euler's phi function, and the function is given in this way. What is the function given like? The function is given in this way. Phi n is equal to k, any k belonging to n such that k is greater than equal to 1 but less than equal to n, provided k comma n is equal to 1. Alright, students, very important part. Okay, you must keep this phi function in your mind. We will be using this while we will be doing mathematics. Now you see, I want to give you a mathematical example with this, how to find the number of cyclic subgroups of G. How to use this formula to find the number of cyclic subgroups of G, this one. So let's try and let us do an example. Okay, so let me get a color that, let's do a black color. Let's say I take G as a group which is equal to Z10. Z10 means integers of there are 10 integers over there. Okay, all positive, suppose. Okay, so let's say Z10 is equal to what? 0, 1, 2, 3, 4, 7, 9, right? So if you do like if you make a modulo, okay, of 10, you make a modulo 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Trying to fit it 2, 3, 4, 5, 6, 7, 8 and 9. Okay, will not show you all of them, just show you a little bit. Let's say 0 plus 0, 0, 0 plus 1, 1, 0 plus 2, 2, 0 plus 3, 3, 4, 5, 6, 7, 8, 9. 1 plus 0, 0, 1 plus 1, 2, 2 plus 1, 3. Okay, now if I continue writing this like this, let's say if I want to generate the group with 2, then the first value what I can get, if I try and generate this group with 2, then the first value I will get is 0. Then I can write 0 plus 2 is 2, then 2 plus 2 is 4, then 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, goes back to 0. So you stop there. Try to generate with 3. So 3 will be 0, of course, first one 0, yeah, then 0 plus 3 is 3, then 6, 7, 8, 9, 10, 11, 12, 12 minus 10, 2, right, 12, so 12, 13, 14, 15, 15 minus again 10, 5. So you know how it's coming, can you understand how it's coming, right? Then it will come 8 and so on. So you see the 2 over here 2. So how this is a type of a generator, isn't it? Now in order to find the cyclic subgroup, let's say for 2, cyclic subgroup of 2, cyclic subgroup of 2. So what is it? It is the element, look, go back to this here. So how do we find the cyclic subgroup? Number of elements of the order D by phi D. Over here phi D will be the same as the number of elements. So it will be, how many elements are there generated by this? 1, 2, 3, 4, 5. So it will be 5 by 5 equal to 1. Understood? Because the 5 will be equal to 5 only. So 5 by 5 will be equal to 1. Alright. So how would you write this? You will not write 5 by 5. You will write phi of 2 divided by phi of 2 is equal to 1. Understood? Similarly, if you have to find the cyclic number of cyclic group of say order, anything you can take, okay, order 5, then what do you get? You will write phi 5 by phi 5 be the same thing, equal to 1. So like that you can find the order of any one of them, okay, like that you can find the order of any one of them. Let's say the order of I want to find the order of 10, okay, then so what do I find? Number of cyclic GRs of order 10, which will be equals to phi 10 divided by phi 10 is equal to 1. You understood, students? Concept is not very difficult, okay, the concept is very, very simple, okay. What you need to understand from here is that how we are getting the generators of the group, okay. If you don't understand how the group is getting generated, right, like 2 is generating those elements. Now tell me, is 2 the generator of this group? If I ask you a question, is 2 the generator of this group? No, 2 is not the generator of this group because it does not contain all the elements of the group, right? So 2 cannot be the generator of this group because 2 is not containing all the elements of the group, right? So Z10 will be generated by I think most probably 1 it would be, I think so. Alright, let me just think of that. It will be generated by, I'll tell you, if I think about 3, then we see that it's 3 is giving us 0 on the look at your screen, okay, that's why I'm looking and trying to tell you. Okay, if you look at the screen, 0, 1, 2, it will be generated by 0. This is 0, 0 plus 1, okay, 0 plus 2, like that, 0, then plus 1, plus 2, plus 3, like that. It can be generated by 0, okay. If it contains all the elements, then it is generated by that element, okay, then it will be generated by that, okay. So you see Z10 is cyclic, that means Z10 is cyclic. So the Z10 is cyclic because it is generated by an element, right? So if the group can be generated by the element, it is cyclic. So it has a unique subgroup corresponding to each divisor of 10. So it has a unique subgroup, corresponding to each divisor of 10. Each divisor of 10. You can see there is a unique subgroup every time. Right? Even with, if you do with 5 here also, here 10, unique subgroup every time, right? You can do with anything. Okay, you can do with say you can do with 7 also. You can try and generate with 7 also. 0, 7, then 7 plus 7, 14. That is 14 minus 10, you get 4. Okay, so you will have to find which is the generator. Okay, and you will come to know how it is happening. Alright, so students, Z10 is a cyclic group. Keep that in your mind. Euler's function, that is the definition of Euler's function. Keep that also in your mind, and keep going ahead with our videos and keep understanding. And if you don't understand anything at any point, let us know. We will clear your doubts. Join our classes if required. If you want to get your doubts cleared even much more, join Sorcerer's classes. Okay, take classes, become better. Okay, and don't worry about exams, because exams will come, exams will go. You will definitely do well. I am hoping that all of you will be watching these videos and will be doing well in your exams. Don't worry, we will go on to core mathematics with this, and that time you will have fun, okay, solving the questions. That's it for today, students. We will continue this in the next part. Thank you for watching. Take as much help as possible from Dr. Sorcerer's classes, because all the help that you'll be needing will be provided here at Sorcerer's class. Bye bye, students.